Alrighty, can you guys hear me?
Yes.
Alrighty. All right, let me go ahead and start my timer. Okay, hello everybody. My name is Evan Gallagher and I have been working on an application that uses wind data to track how nitrogen dioxide moves. So just to remind you, why do we care about nitrogen dioxide? This is an air pollutant that mainly comes from traffic as well as some of the dirtier power plant operations. And it's a problem in quickly industrializing urban centers like we see in China right now. So this last bullet point is just an academic paper that shows even just 30 minutes of some of the regular exposures that they experience can heavily negatively affect bronchial responsiveness. So an app that can show users these concentrations and maybe even where they're coming from could definitely be pretty broadly applicable. So that makes my goal to get these live satellite data sets to interact with each other for meaningful results, and then hopefully build out an application from there with that results. So take a look at the data sets. This is the top one is the actual nitrogen dioxide data set, more commonly referred to as TRPOMI, and that's how I'm gonna refer to it. And the one on the bottom is the Global Forecast System's atmospheric data, which can be used to determine wind direction and magnitude. So my approach was through Google Earth Engine, which is a cloud-based coding platform that is integrated into Google Earth. And this platform takes data points and maps them as pixels, and then each one of these pixels is capable of complicated coding functions and even math equations. So with that in mind, my goal becomes to take this TRPOMI NO2 data and essentially apply the wind data set as a vector to the TRPOMI. So since Google Earth Engine is global, it's helpful to break it down to a smaller area. And the area that I chose was Pawnee Generating Station, which is in Brush, Colorado. And this is a power plant that primarily burns coal as well as other things. So it's got high concentrations of nitrogen dioxide that you can see here. And I think this image is really good for explaining why this project was picked, and that's the data uncertainty in TRPOMI. So you can see around the generating station, there are these high spikes of nitrogen dioxide concentrations, which you'd expect, but there is also some concentrations to the northwest, which you would not expect, because if you take a look at the study area on that image on the left, it's mostly just lakes and grasslands where you would not be expecting high concentrations of nitrogen dioxide. So the math that I used, I think, can be broken down into this equation LVW, L being the ratio of nitrogen dioxide to the other oxides of nitrogen, V being the tropospheric column concentration, essentially what we're pulling from the TRPOMI data set, as well as the W being the wind, and we're using that as a vector to move this TRPOMI data set. So my results, unfortunately, were not quite what I wanted them to be. This was about the best I could get. And you can see it really heavily skews those values towards the lower end rather than condensing the red values around the Pawnee generating station. So that leaves me with some obvious next steps of working on the code myself, obviously. And I have some theories on what could be wrong, and maybe just the LVW. I actually, when I just did that math equation, I think I got some pretty meaningful results. But that's leaving out a lot of the more complicated things, such as maybe the chemical half-life. I think I might have oversimplified that a little bit, and that could be skewing my results too far down. Maybe even the gradient could not be scaled to the correct pixel size, so that would imply that I have correct data values, but there's too wide of a gradient, and so it's placing it all on the lower end. But there's also some next steps that I could take for the greater scientific community. Google Earth Engine is really useful in that you can share things easily. I can just take a snapshot of my code essentially, and it gives me a link. And with that link, I can send it out to anybody who would be able to open it in Google Earth Engine and run my code and maybe even edit it. So I could make my code as clear as concise as possible, so anybody who wanted that code could be able to expand on what I've done. So that's where I'm at right now, and I just wanted to thank a few of the people who have helped me a lot. Kari Klein is the Google project partner who's been wonderful in helping me get to where I'm at in my project, as well as obviously the course instructors, Jenny and Leah, who have been absolutely instrumental in helping me get to this point. So that's where I'm at right now. Thank you guys very much, and I hope you enjoy the rest of the presentations.